We have mapped the surface of Mars with incredible precision. We have sent probes to the outer reaches of our solar system and peered back in time to the very birth of the universe. Yet, right beneath our feet, just a few miles down, lies a world as alien and unexplored as the farthest galaxy. For decades, humanity has dreamed of touching the beating heart of our planet, the mantle. But every attempt has been met with crushing pressure and scorching heat that turned our best tools into scrap metal. That is about to change. In early 2026, a massive vessel named the Mengxiang set sail on a mission that sounds like something out of a Jules Verne novel. Its goal is not to sail across the ocean, but to go through it, drilling deeper into the Earth's crust than anyone has ever dared. This is the story of China's journey to the mantle and the ship built to unlock the final secrets of our world. The Mengxiang is not your average research vessel. Stretching 180 meters in length and weighing tens of thousands of tons, it is a floating fortress of science. The name itself translates to dream, a fitting title for a project that has been the holy grail of geology for over a century. While the world has seen its fair share of impressive drilling rigs, nothing quite compares to the sheer scale and technological sophistication of this Chinese powerhouse. It is designed to operate in the harshest conditions imaginable, capable of remaining stable in the middle of a typhoon while keeping its drill bits centered on a target miles below the waves. This isn't just about making the deepest hole on Earth in the ocean. It is about reaching a boundary that has remained a theoretical line on a map since the early 1900s. To understand why this mission is so monumental, we have to look at the structure of our planet. We live on the crust, a thin, brittle shell that is essentially a layer of peach skin on the scale of the entire Earth. Beneath that crust lies the mantle, a massive layer of rock that makes up 84% of the Earth's volume. The mantle is what drives everything from the movement of continents to the eruption of volcanoes. It is the engine room of the world. However, between the crust and the mantle sits a mysterious transition zone known as the Mohorovičić discontinuity, or simply the MOHO. Reaching this line is the ultimate objective for the Mengxiang expedition. You might wonder why we don't just drill on land. After all, we have plenty of space on the continents. But the continental crust is thick and stubborn, often reaching depths of 30 to 40 miles. Drilling through that would be like trying to poke a needle through a thick brick. The oceanic crust, however, is much thinner, usually only about 3 to 5 miles thick. By starting at the bottom of the deep ocean, the scientists on the Mengxiang are taking a calculated shortcut. But even a shortcut through 5 miles of solid basalt and gabbro under the weight of several miles of seawater is a Herculean task. The pressure at those depths is enough to crush a submarine like a soda can, and the friction from drilling generates temperatures that can melt standard industrial equipment. This brings us to the technological marvel that is the Mengxiang itself. Launched with the backing of the China Geological Survey, the ship is a masterclass in engineering. It features a unique derrick system and advanced deep-sea drilling tech that can reach a total depth of 11 kilometers. That is nearly 7 miles of vertical distance. To put that in perspective, if you were to drop a stone from the top of the drill string, it would take a significant amount of time just to reach the bottom. The ship uses a sophisticated dynamic positioning system that relies on satellite data and underwater thrusters to stay perfectly still. If the ship moves even a few feet in the wrong direction, while the drill is thousands of meters deep, the entire drill string could snap, ending the mission instantly and costing millions of dollars. But the Mengxiang is more than just a big drill. It is essentially a floating city of laboratories. Covering thousands of square meters, these onboard facilities are some of the most advanced in the world. As the drill bit grinds through the layers of the oceanic crust, it brings up core samples, long cylinders of rock that have been buried for millions of years. These samples are the primary treasure of the expedition. On a normal research trip, these rocks would be boxed up and sent to a land-based lab weeks or months later. On the Mengxiang, they are analyzed in real time. Scientists can look at the mineral composition, the magnetic orientation, and the chemical signatures of the rock the moment it reaches the deck. This real-time analysis is crucial because some of the secrets these rocks hold are incredibly fragile. Some minerals only exist in their specific form under the immense pressure of the deep crust. Once that pressure is released, the minerals can begin to change. By having the labs on board, the team can capture the data before the samples lose their integrity. They are looking for tectonic secrets that could explain how the Earth's plates have moved over the last several 100 million years. They are searching for ancient life forms that might exist in the deep biosphere, organisms that live off the heat and chemicals of the Earth rather than sunlight. The quest to reach the Mohorovičić discontinuity is also a quest for better disaster prediction. Most of the world's most powerful earthquakes occur at subduction zones, where one plate slides beneath another. By drilling deep into the crust near these zones, the Mengxiang can help scientists understand the stresses and strains that build up before a massive quake. If we can understand the physical properties of the rock at those depths, we might one day be able to develop better early warning systems, potentially saving thousands of lives. It is a rare example of pure scientific curiosity having a direct, tangible benefit for human safety. Historical context is important here because China is not the first to try this. In the 1960s, the United States launched Project Mohole, an ambitious attempt to do exactly what the Mengxiang is doing now. They managed to drill a few hundred feet into the seafloor before the project was canceled due to ballooning costs and political infighting. Later, the Soviet Union took a different approach with the Kola superdeep borehole on land. They reached a staggering depth of over 12 kilometers, which still holds the record for the deepest man-made point on Earth. But because they were drilling on a continent, they were still nowhere near the mantle. They hit a wall of heat that made further progress impossible. The rocks at the bottom were behaving more like plastic than solid stone. The Mengxiang expedition represents the next logical step in this long-running human drama. It is benefiting from decades of advancements in material science. The drill bits used today are tipped with synthetic diamonds and specialized alloys that can withstand the brutal environment of the deep crust. The mud and fluids used to lubricate the drill are chemically engineered to cool the bit and carry the crushed rock fragments back to the surface efficiently. Every foot of progress is a hard-won battle against the laws of physics. As the ship moves through its mission cycles in 2026 and beyond, it will be focusing on several key areas of the Pacific and Indian Oceans. These locations are carefully chosen where the crust is believed to be thinnest and the mantle boundary most accessible. Each core sample pulled from the depths is like a page in a history book that has been sealed for eons. These rocks tell the story of the Earth's cooling, the formation of the oceans, and the recycling of material back into the interior of the planet. It is a cycle that has been going on for 4.5 billion years, and we are finally getting a look at the mechanics behind it. The significance of reaching the mantle cannot be overstated. It would be the geological equivalent of the moon landing. For the first time, we would have a direct sample of the material that makes up the bulk of our planet. We would be able to test our models of Earth's chemistry and temperature. Everything we think we know about the interior of the Earth is based on indirect evidence, mostly from seismic waves produced by earthquakes. It is like trying to guess what is inside a gift-wrap box by shaking it. Reaching the mantle is like finally opening that box and seeing what is inside. Beyond the geology, there is a sense of national pride and global competition involved in the Mengxiang mission. It signals China's emergence as a top-tier power in deep-sea exploration. The ability to build and operate a vessel of this complexity is a clear demonstration of engineering might. But the data gathered by the ship will be of immense value to the entire global scientific community. Science at this scale is rarely a solo effort, and the insights gained from the oceanic crust secrets revealed by the Mengxiang will likely fuel research papers and textbooks for decades to come. As the drill moves deeper, the curiosity loops for the scientists only grow. What will the boundary actually look like? Will it be a sharp transition or a gradual change in rock type? Will they find unexpected pockets of water or gas trapped miles down? Every time the drill string is pulled up, the entire crew holds its breath. The samples they retrieve are a physical connection to the deep Earth, a place that was once considered reachable only in our imagination. The Mengxiang is currently the only ship in the world with this specific set of capabilities. It represents a massive investment in the future of Earth science. As the expedition continues to push the boundaries of the known world, it serves as a reminder that there is still so much to discover right here on our home planet. We don't necessarily have to look to the stars to find new frontiers. Sometimes the most incredible discoveries are waiting for us just a few miles down, hidden beneath the waves and the rock. The journey of the Mengxiang is a testament to human persistence. It is the culmination of a dream that started with the very first geologists who realized that the ground beneath us was not a static, solid mass, but a living, moving system. As we move further into the 2020s, the results from this mission will likely change our fundamental understanding of how our world works. It is a bold, risky, and incredibly expensive endeavor, but the potential rewards are nothing less than a complete map of our planet's history. We are standing on the edge of a new era of discovery. Just as the great explorers of the past mapped the outlines of the continents, the crew of the Mengxiang is mapping the vertical dimension of our world. They are the pioneers of the deep, venturing into a high-pressure, high-temperature wilderness to bring back knowledge that will benefit all of humanity. It is a journey that requires equal parts bravery and brilliance. If you found this exploration of China's journey to the mantle as fascinating as I did, it is an incredible time to be following the world of deep-sea science. We are watching history being made in real time as the Mengxiang pushes deeper into the crust. If you enjoyed this video and want to see more content about the engineering marvels and scientific breakthroughs that are shaping our future, please give this video a like. It really helps the channel reach more people who share your curiosity. What do you think is the most exciting thing they might find down there? Is it ancient life or perhaps a better way to predict earthquakes? Let me know your thoughts in the comments below. I love hearing your perspectives and seeing the discussions that happen there. And if you haven't already, make sure to subscribe and turn on the notification bell so you can stay updated on all our latest deep dives into the mysteries of our planet and beyond. Thank you for spending your time with me today, and I will see you in the next one.